Hello, my name is Ann Gilcrease, and I'm excited to share a few key terms with you today that will better help you understand what our MAP growth tests are and how to use them to support your students. Our MAP growth tests provide accurate, actionable evidence of each student's learning progress, regardless of their starting point. Given at the beginning, middle, and end of the school year, these tests help educators set growth goals, monitor progress, and better prepare students for grade level standards. This process starts with our Computer Adaptive Assessment, or as I'll be calling it from now on, Computer Adaptive Tests, or CAT. Our CAT is a trusted and innovative tool for measuring achievement and growth in K 12 math, reading, language usage, and science. The computer adaptive test adjusts the difficulty of questions based on a student's responses, providing a reflection of their proficiency level in the subject. This adaptive nature ensures that students are engaged and challenged at an appropriate level. By pinpointing students' strengths and weaknesses, adaptive testing enables teachers to better target instructional materials and programs, ensuring that all students receive the support they need to succeed. Treating students as if they don't have differences in achievement is not a rational way to help all students succeed. By providing assessment information tailored to each student, adaptive testing enables teachers to better target instructional materials and programs. Here's a student test taker's progression sample. The sample item progression shown here illustrates how item difficulty is adapted for students over the length of a 20-item test. The student responds to the first two items correctly. The third item, which is more difficult, is presented and responded to incorrectly. This causes a slight drop in the ability estimate, and the fourth item therefore becomes easier. This process continues until all 20 items are administered. The standard error of measurement, an indicator for measurement precision, shrinks as the test proceeds. Toward the end of the test, at approximately item 10, the test taker's ability estimate starts to stabilize. After your students have completed their computer adaptive tests, schools receive student progress reports, one of the many data captures the MAP growth test provides. But how do we interpret the data that comes out of these tests? Well, we first have to understand what we're looking at, and that starts with understanding how it's scored. MAP growth measures students' performance with our RIT scale. NWEA's RIT scale stands for Rash Unit Scale, and the RIT scale measures student performance over time and across subjects. The RIT scale is stable, equal interval scale used in reading, language usage, mathematics, and science assessments. A student's RIT score represents their level of learning on a continuous scale. It is not evaluative, but tells us where a student is at a given point in time, helping educators understand their growth. A student's RIT score represents their level of learning on a continuous scale, similar to measuring a student's height with a yardstick. Like we said earlier, it's not evaluative, but tells us where a student's at a given point, which is incredibly helpful for setting yourself up for successful instruction. RIT scores allow us to track a student's educational growth from year to year. They typically range from 140 to 300, indicating the difficulty level at which the student is answering about 50% of questions correctly. These scores are accurate and reliable due to normative data. Normative data ensures the accuracy of RIT scores by calibrating computerized adaptive tests using assessment data from over 11 million students nationwide. Because CATs require a large pool of questions to pull from to calibrate that common measurement scale that we rely on, NWEA's MAP growth test results have built a reputation in education that is based on trust. With this data, we can interpret individual reports for individual students based on grade level norms, which provide a reference point for understanding student performance. For example, grade 2 students in the fall had a mean RIT score of 172.35 and a standard deviation of 15.9, indicating the expected range of scores. And we provide these charts for you to be able to understand your student achievement norms. If we look back, you'll see that if you look on our RIT scales, in the middle, you'll notice where the student lands in the center and then the standard deviation on either side. It'll also show that RIT growth, and it'll also let you know what percentile range they land in. Student level norms are inappropriate for understanding the performance and progress of groups of students, such as a grade level or across school or schools. Instead, school norms allow us to compare the performance of grade levels within a school to those in other schools or public schools across the U.S. This helps administrators monitor school performance over time and compare schools within a district. School norms provide valuable insight into how student groups perform relative to each other and to national averages. Map growth RIT scores also help establish students' zones of proximal development, or ZPD. ZPD is the difference between what a student can do independently and what they can do with targeted assistance, such as in a classroom or in a one-to-one setting. Psychologist Lev Vygotsky coined this term to describe the ideal level where instruction is most beneficial for each student, just beyond their current level of independent capability. Instruction within each student's ZPD or zone of proximal development is challenging enough to develop new skills, but not overwhelming. The ZPD changes as students learn and grow, making it essential to understand and locate it. Map growth assessments and classroom assessments can help identify students' ZPDs, allowing educators to plan more targeted instruction for whole classes, small groups, and individuals. Those early years are especially critical because brain development is at its highest, and research shows children who receive quality education when they're very young are less likely to be placed in special education, less likely to be retained in a grade, and more likely to graduate from high school than peers who didn't attend such programs. The common thread between formative assessment practices and the practice of identifying and teaching within the ZPD is the idea that in order for teaching and learning to be effective, instruction should focus on skills and knowledge that are attainable for students. With constant feedback or scaffolding, we know that students' learning and understanding can continue to develop at an appropriate rate. Understanding and using students' zones of proximal development, or ZPDs, can greatly enhance classroom instruction. By identifying where students need support and where they're ready to learn next, educators can tailor their teaching strategies to meet individual needs. For example, when students are in the ZPD, instruction is at an appropriate level, neither too difficult nor too easy, fostering optimal learning. Formative assessment practices can complement the use of ZPDs in instruction. By analyzing student performance, educators can gauge whether instruction is within the ZPD. For example, if students score below 35% accuracy as a class, the content may be too challenging. If the scores fall within 36 to 69%, instruction is within the ZPD. Scores above 70% may indicate that the content is too easy, requiring adjustment to increase complexity. Adjusting instruction based on these assessments ensures that students are appropriately challenged and supported in their learning. In conclusion, understanding key terms such as the computer adaptive test or assessment, RIT scale, zones of proximal development, is crucial for effectively utilizing MAP growth tests to support student learning. By analyzing data from MAP growth assessments and interpreting RIT scores through the understanding of normative data, educators can identify student strengths and weaknesses, track their progress over time, and tailor instruction to meet their individual needs. I hope this information empowers you to use MAP growth tests more effectively in your teaching practice. By understanding and interpreting the results, you can guide your students on their learning journey and help them reach their full potential. Thank you for your time.